Hello everyone, welcome to the seventh module of this course. Today we will learn about virtual environments, testing, and CICD basics. Also, before that, from the previous lecture, that is object oriented programming. Basically, object oriented programming is a programming paradigm based on the concept of objects, which we learned about in the previous lecture, or maybe I think the lecture before that. I believe you figured this bit out, but I think I never mentioned this that what exactly object oriented programming means. I don't think I mentioned that, and I'm really sorry about it. So, yeah, so here it is. Basically, object oriented programming is basically programming dealing with objects. Yes. Okay, so let's start today's lecture. First up, we have virtual environments. So, we had previously talked about virtual environments. A virtual environment in Python is a self contained directory that contains all necessary files to run a Python project, including specific versions of Python and the project's dependencies, that is, libraries or packages. It allows you to create isolated environments for different Python projects, which can have their own dependencies without affecting other projects on your system. So, why isolate dependencies? To prevent dependency conflicts. Different projects might require different versions of the same package, and installing them globally could lead to version conflicts. Simplify dependency management. A virtual environment allows you to track and manage dependencies of a specific project in a clean and organized way. Avoid polluting the global Python environment. Installing dependencies globally can clutter the system's Python environment, making it harder to maintain and debug. By using virtual environments, you keep your system's Python environment clean. Here, the system's Python environment means the Python in your system as a whole. Ensure reproducibility. Using a virtual environment ensures that everyone working on the project or any future deployments will use the same version of the dependencies. Security and compatibility. Certain dependencies may have security vulnerabilities or compatibility issues with each other. By isolating dependencies in different environments, you can reduce the risk of these issues affecting unrelated projects. Cleaner development workflow. Virtual environments make it easier to experiment with new libraries or versions without affecting other projects. So, all in all, virtual environments are needed because we want to have a singular project which is not dependent on any other projects. We can work specifically on the said project without affecting the other project on the same system. Moving on, we have managing environments. We had also talked about venv and conda previously. venv or venv is a module in Python standard library available from Python 3.3 onwards that allows you to create lightweight, isolated Python environments, while conda is a package and environment management system that is a part of the Anaconda distribution, which is widely used in data science and machine learning. We'll be discussing venv in a more detail today. So venv is a built-in tool. It is also Python only. venv is designed to manage Python environments only. You cannot be managing any other environments of any other languages using this. Lightweight. venv environments are lightweight and contain only the standard Python libraries. So let's check out how to create an environment using venv. I believe we had discussed this earlier, but again, so this is VS Code. We go to terminal here, new terminal, and then we type Python -m with no space between minus and n, venv myenv. So you can see here we have the new environment that we just created. So for activating the new environment, so as to work in it, we have to type source mynv /bin /activate. Enter. So now the environment is activated and we can use it. Also, the code that I just wrote, that is source mynv bin activate, this is only for Linux systems. In case you want to use Windows systems, which I believe most of you are using, in that case, the code here changes to this. Scripts activate. So in case you are using a Windows system, this is what you have to do to activate the new environment. Okay, so now the environment is activated, and if we want to install any package here, we can just use pip install and the package name. So it's that easy. And when we are done using the environment, we want to deactivate it. So what we do is we just type deactivate. So here it is. Now we have come out of the personal environment that we had created, and so it's deactivated now. Okay, next we have testing. Testing is a critical part of software development in Python, ensuring that your code is correct, reliable, and maintainable. Python provides several tools and frameworks for testing code. Common Python testing frameworks are Unit Test, which is a built-in framework, and PyTest, which is a popular third-party framework. So let's check this out in programs. Here we create a new file, Python file, and we write import. First we'll check out unit test. Def add a comma b, return a plus b. Next we define a class which is needed for the unit testing. Test function, say unit test dot test case colon def test underscore add self colon self dot assert equal similarly say -1 comma 1 equals 0. So this is for the test actually passing. Then we have def test add fail self. Say 6. Okay, so let's run this and check it out. So here the test has been successful, and you can see that the test, like we ran 2 tests in 0 seconds. It also gives you the time. So the test case class is used to create test cases. Assert equal checks if the result is as expected, and unit test.main runs the test when the script is executed. So here we have to create a class um, which is called test case, and which will test the required functions if they are satisfying or if they are failing. And then we'll have to write this part to actually execute the unit test framework. So this was for unit test. Now let's check out for PyTest. So first of all, you have to install it, since it is a third party framework. Pip install PyTest. We have to write it down in the terminal. So this is how it is being installed. I think this is the first time you guys are seeing any module being installed in the lecture video. Yeah, because before this, I think I already had everything installed, and like I could never show you this. So yeah, this is how things get installed, and you can see it here, successfully installed. So yes. So now we can just write here. We can just modify this code only. Def add. In this case, we don't need to define a class. So self is removed as well. So here we are trying to remove self from wherever it occurs. For that, I used this part. So in case you want to remove anything you've written in the program, like every time you've written it, you have to go here. Like in case you're using VS Code, you have to go. Suppose you want to remove assert equal, so you can right click on the word and you can click on change occurrences, and you can just rename it or maybe delete it. So okay, so here we have to change this. We have to write assert add 2 comma 3 equals 5 and -1 equals 0. Similarly, in test add fail, we have to write something similar. So here it will be 6 and this will be not equal to. I hope you remember, this is how we write not equal to, exclamation mark and equal to. So here we just remove this part. Okay, so let's check it out. So here we also ran the test. You can see that we ran the test here. So let's save the file. Mm. Say test.py, and then to run the test here we can write python test.py. Okay, so this was actually saved somewhere else. Um, all right. Did can we? And I could go here and okay, this was saved somewhere else, which is why it's showing me the thing. I'll delete and save it again. Alright, never mind. So basically, I removed the whole thing. Okay, so A comma B return A plus B def test add. So you can understand that using PyTest is a lot simpler and I guess easy to understand than unit test. It has a bit simpler code and you don't have to define a class or anything. So it's understandable why PyTest is used more often rather than the built-in framework. Dev test fail. So here we write 6 and then we write not equal to. So this time I'll make sure I save it well. So let's say test.py and this time we have saved it in the the original folder. So to activate to run test, we use Python, sorry, test.py. So here basically if you had just run the test, the test would still like go on. So basically in this case the test functions are incorporated within the code and like even if there's no message displayed in the like output, like you could have done this anyway, you could have inserted a print statement anywhere. So since like even if the message isn't displayed in the output, the test is still being run. Okay, so this was the PyTest framework. Next, we'll have test driven development or TDD. So, test driven development is a software development approach where tests are written before writing the actual code. The idea is to focus on the behavior of the code from the start, ensuring that all code is thoroughly tested and behaves as expected. Key principles of TDD are write a test, run the test. Since the function or feature hasn't been implemented yet, the test should fail. This is an important step as it shows that the test is working as expected. Then we write the code and run the test again. After writing the code, the test should pass if the program is working correctly. Then we refactor the code. Refactoring is the process of improving existing code by restructuring its internal design without changing its external behavior. This is done for better design or readability while ensuring that all tests still pass after refactoring. Repeat the process. So then we just simply repeat the process for different functions and tests. So we'll check it out this time again. This time we'll write a different code. Import PyTest. Also, I guess previously I did not import PyTest. So yeah, you have to import PyTest before like let's see. Import PyTest. I mean obviously since like we also imported unit test, right? So yeah, you have to import PyTest for this test thing to run. Okay, so next we have, say we write a different code, say prime. Okay, let's name it test prime. Okay, so we'll write assert is prime 2 equals true, as we know that 2 is a prime number. Then 3 will also be a prime number. The next prime number is 5. And in case you don't know what a prime number is, then a prime number is a number that is divisible by only 1 and itself. Like it does not have any other factors. For example, 5 can only be divided by and leaves no remainder only if it is divided by 5 or 1. Similarly, 7 also does the same. Like it can be divisible by 7 and 1 only, and 2 and 3 also do the same. Then we'll test some non-prime numbers. Say, what is the first non-prime number? Or composite number, I think that's what they are called. Yes, composite numbers. So here we'll write false. And as you can see, 4 can be divisible by 4 itself, 1 and also 2. So it's not a prime number. The next prime number is 6, which is, apart from being divisible by 6 and 1, it's also divisible by 2 and 3. And then there's 8. And you can keep adding numbers like that. Also, 1 is also not considered a prime number. 1 is a unique number. So, yeah, it's neither prime nor composite since it can only be divided by 1 itself. Like it doesn't even have two factors, it has just one. Okay, so this is our test.py. And let's run the test. Okay, like we have written a test and let's run it. Okay. So in this case, we have to write $py test. And you know that the test is going to fail. So yeah, the test has failed since the function of is prime is not defined yet. So the test has failed now. Let's write another program in a different file and we'll say write the function of prime. So if n is less than equal to 1 colon, the function will return false. Since 0 is also not a prime number and we just discussed that 1 is also not 1. Not a prime number, I mean. Then we have for I in range 2 comma n. So the loop goes from 2 to n, which is the number. If n modulus I equals 0, which means that n is completely divisible by I, then we return false. So I hope you understand the code. So the loop goes from 2 to n minus 1 basically, it does not go up to n. And if the function finds out that between 2, like from 2 and n minus 1, 2 to n minus 1, there is a number or like multiple of them which completely divides the number n, then it returns false because this means that the number has more than two factors. Like it is divisible by other numbers, like numbers other than n and 1. So otherwise, we can return true. So let's save it. This can be named prime.py. So here we have already saved it, but we have to import it in the program, right? So like to use it in the program, we have to import it. So we'll write from prime, which is the name of the file, we will import prime, which is the function. So let's say just to differentiate it, we'll write import prime as say is prime. So yeah, prime, the function that we had mentioned here, defined here, is imported into the function into the file called test.py as is prime. Okay, just to differentiate it. You could have just written as import prime and used like instead of is prime, you could have just used prime here. So now let's run the code and check it out again. So in this case, the test is actually run and it gives us the result of 2. So yeah, so in this case, the test run is successful. And next up, we had the steps of refactoring and repeating the whole process. So in this case, the code is already simple, so no refactoring is necessary. However, in more complex cases, you might want to optimize the code without breaking the tests. You would continue this process for any other function, gradually building your software piece by piece with tests driving the development. So TDD ensures that you know immediately if your code is working as expected. Having a comprehensive set of tests give you the confidence to refactor and optimize the code. With continuous testing, you are more likely to catch errors early, reducing the time spent on debugging. TDD is often used in continuous integration or continuous development, that is CICD workflows, as it helps ensure high quality software with fewer defects. It is especially useful in projects where requirements are constantly evolving and you want to ensure that changes don't break existing functionality. We'll learn about CI/CD later in the same module. So now we've come to the end of this video and it's time for a quick recap. So we started off with virtual environments and managing them. Then we tried out testing with unit test and PyTest. And finally, we learned about test-driven development or TDD. So we started the 7th module today, which we'll continue in the next lecture. As always, let me know in the comments if you have any queries regarding any of the lectures, or maybe if you have difficulty writing your own code, or maybe using any platform, be it VS Code or anything else that you're using. And yeah, any suggestion regarding the course is always welcomed. Alright, so good luck to you guys and see you guys in next video. Bye bye. All the best to you.